Okay, so my next guest today is Marcel Demler from a company called Scia Systems. Welcome, Marcel. Nice to see you.
Thank you.
Okay,
I'm happy to be here.
right. Your company specializes in making ion beam systems and plasma systems, essentially, for the microelectronics process. But you've recently come out with a new product, which is the fail system. I think I've got the name correct. I'm not sure.
It's called a Scia Mill 200 or 300 for failure analysis.
For fail analyzing. Okay. Explain to our viewers exactly what that is.
Yeah. So actually, it's a ion beam etching system we have been selling for many years already. So it's a proven technology.
Yeah.
And over the last years, we saw more interest in a new application, which is called failure analysis, which means our customers who are making some chips, right? They sometimes face the issue that like there's a defect in the chip, it's not working, and now they have to look into the chip and to find out where's the defect.
Yes.
So traditionally this is done with so-called FIB, focused ion beam. You just shoot like certain cuts, and then if you're lucky, you're at the right position and you find your failure or defect, and then you can conclude what was wrong in the processing. But I think as bigger the chips are, that's more and more complicated, and you have to do a lot of FIB cuts, and that's very costly. And what our system can do, we can remove material on those chips on a large area.
With great accuracy.
Yeah, it's using an ion beam etching process. So it's a vacuum processing system. So we have an ion beam source inside, argon ions bombarding the surface and removing basically atom by atom layer. So it's very precise.
Right.
And how is it working? I mean, traditionally those this kind of removal has been done with polishing. So just conventional polishing. That's fine, but it's not very precise. So if you want to be able to get like a depth precision of maybe 10 nanometer or so, with conventional polishing that's difficult. But with ion beam etching, it's easy because it's an atomic process. So we etch atom by atom, right? And how to know where to stop the etching process. I mean, that's a key point.
Right.
And within such a chip, you have like multiple layers of copper. And basically what we do, we have a mass spectrometer integrated into our system. It's called secondary ion mass spectrometer, SIMS.
Yeah.
And this allows us to monitor all the material which is etched at each point in time.
So when you see the peaks coming through in the mass spectrometry system, you can tell you've reached each specific layer.
Yeah, basically you just count the peaks, and then you know, okay, now I'm the 7th layer.
Right.
I stop the process, and then the customers just take the sample out of the tool.
Yeah.
And the analysis itself, that's not in our tool. So the tool is just doing the delayering.
Right.
And then those samples, they go in under an electron microscope or optical microscope. Or maybe they do even probing, right? Electrical probing to find out what was wrong with that chip.
So, I mean, the obvious application for this outside of failure analysis is for reverse engineering.
Yes, right. So I think it's exactly the same tool, and usually it's like different departments within the same company.
Right.
One is doing the reverse engineering for the competitor chips, and the other one analyzing your own chips. But for us, it's the same tool and same technology. Yeah?
Right.
Yeah, that's right.
Right. Yeah.
I think all the companies do it, right?
Well, I don't know. I mean, yeah, I'm sure you must sell a lot of them in China. That's for sure. but yeah, it's an interesting concept, but very necessary. But you're right. I mean, the size of these chips is getting bigger, but also the geometries inside these chips is getting smaller. So the need for something that can etch away at such an accurate level, an atomic level, is necessary.
Yeah, that's fully correct. So a few years ago, we just started with smaller systems for small chips, maybe a few square centimeter, right? And we thought, okay, that's it. We need small systems, cheap lab systems, right?
Yeah.
But now we see more requests for bigger systems, like on 200 millimeter or even on 300 millimeter. And I think this is driven by the like AI chips, which are really big.
Yeah.
And our systems allow to do uniform etching also on those big chips.
Interesting. Yeah, it's a fascinating area. It's one that I hadn't thought about, but it's a good idea. I want to thank you for coming in and telling us about it today.
Thank you for the time.